Hi there. In this video we're going to have a look at something called index laws. So from number we know this type of example. 2 to the power of 3 times 2 to the power of 4 will give us 2 to the power of 7. And the reason being is that if we express 2 to the power of 3 and 2 to the power of 4 in full, it would look like that. So 2 times 2 times 2 times 2 times 2 times 2 times 2 is the same as 2 to the power of 7. And what you will notice if you do many of these examples is that as long as the base is the same, so the base is 2, okay, so 2 is the base, as long as the base is the same, you just add the powers. So 3 plus 4 is 7. We can extend this into algebra. Number really is, algebra is number generalized. So in general, we can say that if we've got a number x and it's raised to a power and then multiplied by the same number, x in this case because we don't know what that number is, raised to another power, we are adding those powers. So this would be the rule here. So x to the power of some number, so let's call it m, times x to the power of n will give us x to the power of m plus n. That means you just add the powers. So here's a couple of examples. X to the power of 4 times x to the power of 3 times x to the power of 7. The base is the same, so we can just add the powers. So that will give us x to the power of 4 plus 3 plus 7 gives us 14. Let's extend this a little bit further. Now we have numbers in front of our x terms. So what you do with those numbers is you're going to multiply those numbers first. So 3 times 9 gives me 27. Now I'm just applying that rule. So x squared times x to the power of 4. Add those two powers, I get x to the power of 6. So 27 x to the power of 6 is my final answer. This next example, again we want to multiply these numbers first. So negative 2 times 7 will give me negative 14. Then I've got p to the power of 4 times p. And that will give me p to the power of 5. So when you've just got a single p like that, there's actually a 1 there. We generally don't put in that 1. Okay, so what else do we know from number? We also know something about division. So if we've got 3 to the power of 6 divided by 3 squared, that is actually equal to 3 to the power of 4. So how does this work? If I write out 3 to the power of 6 in full, I will get that there. If I write out 3 squared in full, I will get that. And then it's just a matter of cancelling. So that 3 cancels with that. In a sense, what we're doing is 3 divided by 3. So 3 divided by 3 is 1. So I actually end up with those two 3's dividing give me 1. So with that pair, I've got 1 times, here's another pair. So 1 times 1. And then I've used up all my 3's in my denominator. So I'm just left with 3 times 3 times 3 times 3 on the top, which is just 3 to the power of 4. So what are we doing with the powers? As long as the base is the same, so the base is the same, we are subtracting the powers. Okay, so subtracting the powers. So in number, another example here, 4 to the power of 10 divided by 4 to the power of 3. 10 minus 3 is 7, so my final answer is 4 to the power of 7. Here is another example here. 12 to the power of 6 divided by 12 squared will give me 12 to the power of 4. In algebra, we can apply this same rule. So say I've got x to the power of 8 divided by x to the power of 5. The base is the same. The base in this case is x. So I just subtract the powers to give me x cubed. Okay, this one here, p cubed divided by p Again, I could just put that 1 there just to show you. 3 minus 1 is 2, so p squared. Let's extend this a little bit further and place some coefficients in front of these letters. So coefficients are, they're just the numbers in front of the letters. So 12 and 3 are the coefficients here. So what you do first is you take those numbers, so 12 and 3, and you want to divide them first. So 12 divided by 3, so I've just got it here. 12 divided by 3 is simplified 4 over 1, which is just 4. Okay, so these numbers here simplify down to 4, and then I just apply my second rule. So c to the power 4 divided by c cubed will just give me c. So my final answer would be 4c. Okay, another example. 9x to the power of 7 divided by 18x cubed. Just looking down here to simplify the 9 over 18. So 9 over 18 simplifies to 1/2. So I've written 1/2 here. And then just applying that rule again. So x, that shouldn't be 5 there, whoops. 7 minus 3 is 4. So x to the power 7 over x to the power 3 will give us x to the power 4. So you end up with, you can either write it like this, or you can write it like this. And of course you don't really need the 1 there, you can just write it as x to the power 4 over 2. Okay, a couple more examples. 32x to the power 4 divided by 8x. So 32 over 8 simplifies to 4. X to the power 4 over x, or divided by x, will give me x to the power 3. So 4x to the power 3 is the final answer there. Okay, just a couple more examples, a bit more of an extension. We can have these sorts of problems happening. So x to the power 4, y to the power 7. Remember, there's an invisible multiplication sign between those letters there. We just don't put them in. So we're going to apply the same rules, but we're just looking for the same bases. Okay, so x to the power 4 over x, or divided by x. I'm just going to put my division bar in. I will end up with x to the power 3 here. Now I'm looking at my y's. So y to the power 7 over y cubed gives me y to the power of 4. And you could have a go at those last two.